Okay, so good morning, everyone. The clock has struck half past. So a very, very warm welcome to day 2 of the conference, the Future Mine and Minerals Conference Tallinn. Some of you were here with us yesterday and some of you are brand new. My name is Lisa Eck. I am a management consultant within mining and minerals. I work at LTU Business, an organization owned by Luleå University of Technology, way up in northern Sweden. And we had some talks among the panelists earlier if we had snow or not, and we still do. We still have quite a lot of snow up here, so that's quite different, but the flowers are starting to appear. So this conference, it's an initiative by the Geological Survey of Estonia. We have Taltech and we have the University of Tartu in collaboration with Nordic Publishing. And Nordic Publishing has been doing this conference for over a decade in Stockholm, Sweden, with a Nordic perspective. So it's a really thrilling thing to do this first one with more Northeastern Europe perspective. So we have around 180 registered participants for the 2 days. We are 73 here today. I think people will come and go a little bit. We have 13 different countries that are registered, so that's quite impressive. So yet again, a very warm welcome to all of you. The conference will be recorded. We are recording as of now. So if you want to view this after the conference, or if you want to send it to colleagues and friends, you are very, very much welcome to do that. And as I said yesterday, in a perfect world, we would all be in the same room. We would all have the opportunity to meet each other face to face and to create networks and contacts and so on. But this is not the case. It's a very special year, but there is a physical conference booked, and that is for 21st to 22nd of September this year. So please track our webpage to see all the details on that. Just a little bit of how this environment works before we move into the very first person you will meet. This is a Zoom setting. So if you move down a little bit, you have a bar in the bottom of your Zoom page. And there you have 2 functions that are good to be aware of. You have the chat function, where you can write things to other attendees and so on, to say if the sound is not working or if you have anything other that you want to share. But then you also have a Q&A function, so that's just beside the chat function, and that's a really good thing for you to post questions, and we would love you to post questions, because today we have 3 speakers and then we have a panel discussion, and for this panel discussion it would be lovely to have some questions from you, the audience. So feel very free to write questions in the Q&A function, and I will try to raise them during the panel discussion. And with that said, I want to introduce you to the very first person you will hear today. Sirli Sipp Kulli, you are the director of the Geological Survey of Estonia, and you will give us some context and an introduction to this conference and to day 2. So over to you, Sirli.
Good morning, and thank you, Lisa. Dear guests, it's really nice to see you again. I hope you were here with us already yesterday morning, and you got some inspiring thoughts and ideas from our speakers already yesterday. It's turning out to be a nice practice to meet with you every single morning. A couple of hours ago, with my morning coffee, I was actually wondering what should I say actually today during my 5 minutes of fame. Well, I hope you allow me to share the thoughts that I just wrote down half an hour ago. The phrase, "we don't have the silver bullet," started to go around in my head. We used that phrase yesterday when trying to describe the situation between the pro and anti-miners. As the communication is everything in such matters, I felt like the word bullet seems not to be the best one here. Although it's a figurative speech and nice idiom, we cannot afford a possible misunderstanding deep down that mining companies or concerned locals should be seen as praise or enemies. So maybe the spring is making me an optimist, but I do feel that we are all in this together. We need to mine the local raw materials in order to securely reach the climate goals. And we do need to mine and process the ores, even to keep the level of our modern life as it is now. And we need to find the solutions together. So therefore, I would like to offer you another phrase: silver lining around the cloud. It's most certain that we do have clouds in the raw material mining and processing world. But Saku Vuori shared yesterday kindly the guiding principles from the Finnish Sustainable Mining Standard. I will not read all given 9 principles out loud, as those deserve much more time and more attention than I have right now. But the principles of transparency, best practice, continuous improvement, respect, and continuous dialogue, I say that those principles create the silver lining around the clouds. I'd also like to add a couple of silver linings on my own, and those are very detailed planning of the mine closing and environment monitoring before the actual mine is opened, and finding bold ideas how to recultivate already mined areas while the mine is still working. That means the locals don't have to wait another 40, 50 years, but can start using mined areas maybe as ski slopes or for water sports and so on. Also, the financial tool that allows the locals to share the profit of a local mine nearby must be in place and must be clear. Alvar was talking yesterday about a new era, and that got me looking for a name for the new era. How about era of taking the responsibility? And I mean taking responsibility by all of us. Geologists and explorers will be responsible for gathering maximum amount of information about our raw materials. Mining and processing companies will take on the responsibility of really minimizing the disturbing effects to the locals, and we all, as consumers of renewable energy and new mobile phone and new electric cars, we should take on the responsibility of how we allow the raw materials to be mined. It is not nice to look at the mirror and think how your new car is made from raw materials mined using child labor, or in the country where CO2 emissions are not taken seriously. That 8-year-old kid in Congo is feeling actually the pain and hunger and joy the same way as our kids do here. The CO2 emission across the globe has the same effect on the climate as it would have here. Only here, in our backyards, we can decide. Do we allow our kids to go to work in the mines instead of school or kindergarten? And do we allow to mine and process the metals without any concern of the environment? We can also decide, do we want to go back living in the Stone Age, in caves, and work with tools made from stone, like Alvar showed us yesterday? So, era of taking responsibility. How does it sound to you? It may sound a bit naive, but then again, I'm not a morning person, so please do share your ideas and comments in the chat. Well, I do get the feeling that I'm preaching to the choir, and I'd like to leave our speakers and panelists the maximum amount of valuable minutes. So, Lisa, back to you.
Perfect, thank you. So let's move ahead with the schedule for today. And we have our first speaker coming from a very far distance. Michael Hitch, professor, Curtin University, Perth, Western Australia, and Tallinn University of Technology. You will be sharing with us the critical raw materials and additive manufacturing, an opportunity for producers. So we are very eager to hear you. We can see you perfectly now, and just go ahead and share your slides.
Okay. Excellent. Thank you, Lisa. Can you hear me okay?
Yes, we can.
Great. Tere hommikust. Now, for those of you, that's really difficult for me to say, because it seems like I left Estonia and I never thought in a million years that I would ever use those words again. But I do say that to my Estonian friends and colleagues, and it's an absolute pleasure to be here. It's a bit crazy here right now. It's 28 degrees and sunny, but we've had one of the very rare lockdowns. So we're all forced to work at home. So this is a very kind of unusual situation for us here in Australia. What I'm going to talk about today is critical raw materials and this idea of adaptive manufacturing and seeing it as an opportunity for producers. Now, these producers that I talk about are not necessarily those that are actually secondary or tertiary users of these raw materials, but even in fact, those people that are in those organizations that are mining it in the first place. When we talk about critical raw materials, we talk about it often in the abstract. We don't really understand, we understand why things are critical, but not necessarily what are they critical for. And really there are three things that is driving this idea of critical raw materials. And that is probably the most important thing, is decarbonization of our systems. Decarbonization of our energy production and distribution, and even consumption of that energy in the form of things like electric vehicles and so forth. The other thing that sort of drives this discussion and this need and this desire to chase critical materials or critical raw materials is this idea of additive manufacturing. And I'll talk about this in a little bit. But this is a new way of looking at manufacturing. We hear this term just-in-time production and just-in-time delivery of parts to a lot of these manufacturing systems, like the automotive sector, where we produce parts that are delivered to the plant just in time. But what about if we're actually manufacturing our own parts on site? And finally, the third thing that's really driving this insatiable, crazy rush for critical raw materials is digital transformation. Now we're living in a world that it is so connected. It's been, we've seen it even over during the COVID time on just how connected we really are and how easy it is for us to be connected. Can you imagine going a day without looking at your cell phone? I mean, I dream about such things, and probably some of you do too. But most of us are checking our cell phone and our electronic devices, whether it be a computer or what have you, every few minutes. Now, that's just a symptom or an example of how interconnected we really are. So let's burn into our presentation here. So a little bit about the context. What actually makes something critical, right? So what makes a material critical? First of all, it's something that is super important to some economic sector or a select part of the economy. Now, what this is saying is that not everything is critical to everybody. So what's critical to automobile manufacturing may not necessarily be critical to the production of wind turbines or renewable energy generation systems. The next thing that sort of drives the context or the idea of criticality is the supply risk. And Sirli kind of hinted at this a little bit. She talked about political risk and economic stability, right? We see this particularly in commodities like cobalt. that are largely produced in the Democratic Republic of Congo, which is going through or tends to go through annual civil wars. It basically thrives upon poverty. It's the mineral sector tends to be driven by crime and organized crime. So there's some stability issues there. The other thing is about production concentration. Well, there's risk to that too. If you look at China when it comes to rare earth elements, they effectively have a monopolistic view or position on rare earth elements. Now we are seeing some production that's coming out of other places and hopefully out of Estonia in the fullness of time. There's potential for substitution, right? That's part of that supply risk is, well, yeah, cobalt is actually something that can be substituted. And we've seen that in the aviation sector, that once the price of cobalt gets to a certain point, then all of a sudden the substitutions come into play, and then the price of cobalt actually starts softening off again. This is actually in the case of producing jet engine blades. Finally, the recycling rate. Obviously, and we see this with some other commodities like steel, that we see a big part of the global steel trade is actually in the form of scrap. In fact, I see it, every day when I'm coming home for work. I live in Fremantle near the port, and I see truck after truck after truck carrying scrap steel to be loaded onto ships to send to China. So that influences and impacts upon iron ore, for example. Now, recycling rate in terms of some of the more special or critical elements like rare earths, et cetera, and dysprosium and these other things really hasn't developed to the point yet. And once we start developing the technologies and the smarts in terms of recycling these things, we will see that possibly these elements will become less critical if there is such a thing, right? Right now, the way that the EU has their critical raw materials or their critical elements, it's either you're critical or you're not. There's kind of an in-between. But maybe one day we'll start seeing some of these things start falling off that list as we become better at recycling them. And finally, you have the environmental and country risk. And again, Sirli definitely pointed this out, that do we really want to be using manufactured products or consumer products that have been built, manufactured, or the raw materials garnered from places where environmental regulation doesn't take place? This is what we call aspirational consumerism, where we actually start buying things based on the environmental performance of the company that's actually producing the product. Apple is a case in point that clearly they're saying, and they're being the leaders of this, saying that the components that's going into their electronics does not come from conflict or child labor. So these raw materials are key enablers, right? I got to get rid of this thing that's on the side of my screen. All your pictures are there. There you go. They're all enablers for our economy, that they're prerequisites for developing our strategic view and our strategic sectors. And our sectors, as I pointed out, are things like renewable energy, which is the decarbonization of our energy sources, electric mobility, defense, aerospace, and digital technologies. Really, they all sort of fit into this major bucket. And I mean, the diagram on the side really shows the major components or the major things that really are that our critical raw materials go into. Most of nations around the world are dependent on imports, and they have very deeply exposed value chains. And this is something that we have to talk about. In the European context, we always talk about security of supply. That's really the thing that drives the European discussion or the dialogue, is this security of supply. Where am I going to get this stuff? Now, in some cases, if the political will was there, we could actually go out and mine some of it. But even then, it's arguable that the needs of these critical raw materials would be sufficient, or would be satisfied by what we could produce domestically. So we're constantly looking out, right? So looking out for new sources. So again, you've got this sort of group of consumers that use most of these critical raw materials. Now, these sort of things are really identified by a couple of things, and this kind of goes back to your industrial engineering thinking, that it's all about installed capacity, right? It's all great and fine to say, yes, we need critical raw materials to do this, but if we don't have installed capacity, then how critical is it really? Or the plant lifetime, that if we're only producing plants that have short periods of time, is it really that critical? Some other things like market share, right? Is it a meaningful part of your economy? Does that drive the criticality of the materials? And then finally, the mineral and what's called material intensity. How much really gets used? If you're only using a few tons or a few kilos of this material annually, is it really that critical? So these are some things to think about when we're talking about criticality of raw materials. So there's some opportunities, right? This is the opportunity in the critical raw material space. I think we can grow in the resource technologies by developing technologies that drive operational efficiencies. We can develop products that support sustainability and productivity. We can develop technologies that recover value from waste. And finally, develop cross-cutting manufacturing technologies. So these are ways of actually building upon our economy, I suppose, as it talks about critical raw materials, but also how we more smartly, I mean, I'm trying to think better ways of using the English words, but more intelligently using these raw materials. And then there are opportunities in, growth opportunities in the critical materials and minerals themselves, right? Let's get more value out of our critical raw materials, right? We tend to do this. We tend to, focus in on one use for that material or one application for that. Well, we have to look at alternate values or alternate uses to get the biggest bang for our buck. We have to look at advantages through commercialization and innovation. And Europe is particularly good at this with things that the EIT is doing, with things that Horizon 2020 and other aspects of the Commission are doing. They're doing a pretty good job at this. But again, we got to look at ways of leveraging what we have. And then finally, oops, my spelling mistake there, is leveraging the environmental, social, and governance credentials of what we have in Europe. And I think this is a really important thing. And again, Sirli touched on this, is that, for aspirational consumers and aspirational manufacturers that are looking for ethical raw materials, Europe is a pretty good place, right? The ESG risk is quite manageable in Europe. So something to be very cognizant of. Here's just a couple of examples, right, of how critical raw materials are used. And I only picked a couple of really highlights, the ones that we always hear about, right? So here we have lithium ion battery technologies. And again, we use nickel, cobalt, aluminum, magnesium, graphite, niobium, etc. Right? Europe only produces 1% of the batteries. Okay. The DRC produces most of the, or supplies most of the cobalt, lithium in Chile, and not all the nickel that we produce is suitable. Yes, in Finland, they're developing the ability to produce nickel sulfate, but again, it's tough because of the volatility in nickel prices. So you've got some strategies, you diversify supply, you recycle, you reuse, and you also substitute. But do we really need to be producing batteries, right? We're only producing 1% of the battery materials. Maybe we're reaching a little bit too far. Same thing with wind turbines, right? With rare earths, right? You can see here that there's a whole suite of rare earths, the red ones in particular, that fall under the critical raw materials list of Europe, right? So definitely the most cost-effective for climate change mitigation. But again, we don't have most of the rare earths that are required to produce these things. Should we be producing them? Or should we be producing things that we actually do have the critical raw materials for? These are tough questions. Now, finally, the last part of my talk, and I'll be super quick, is about additive manufacturing. And this is all about 3D printing. We've all kind of heard about 3D printing, and yes, you can sort of print these little funky plastic things and shapes and stuff. But it actually is remarkably advanced technologies. And what it can do is it can deeply disrupt traditional supply chains. And this is where we start moving from the critical raw materials to additive manufacturing. That we can actually start using the materials that we do have and start actually producing parts and producing pieces for our manufacturing sector right on site, and not having to ship things off, raw materials off, and to have the final product returned back to us. 3D printing is awesome in terms of prototyping, and it allows us to produce pieces and manufactured parts that are much lighter weight and much thinner walled, but still retain their strength and sort of mechanical properties that we need. Also, what we're doing here in Australia, we just kicked off a $2.5 million project, is looking as developing new metal powders and what we call intermediate alloys and metalloids. So these intermediate alloys are, in the days of steel making, you produce iron ore at 65%, you produce carbon to make coke, you put limestone and you make steel. Well, now we're looking at making steel or metal powders at much lower iron contents. So what that means is we're using far less energy to produce the steel, we're producing less CO2, et cetera. So we're using these 3D printers to start testing out, looking at these different types of alloys. We're also mixing metals with polymers. So we're creating kind of this thing called a metalloid, which is showing that we can actually produce things that have the same strength or even higher strength than structural steel, but with a polymer and a metal blend. So by using 3D printing, we're able to sort of test that out. The advantage. Basically, for producers, you can look for reduction, substitution, and recycling in terms of critical raw materials, and turn it into traditional or basically substitute for traditionally manufactured components. The market will likely grow to it will grow by 50% in the next 5 years, particularly with aerospace, automotive, and medical devices leading the way. The EU is a major supplier of processed materials, particularly the ones that are required for 3D printing technologies. They actually control about 54% of the world's market. The bottleneck in the supply chain, of course, is raw materials. So if you as producers are producing a raw material that isn't your traditional concentrate or semi-refined material, you may be able to produce a material that actually goes straight into the supply chain for additive manufacturing. And again, it's all about maintaining EU competitiveness. So this gives you a great opportunity to maintain competitiveness. That's all I have to say. Thank you.
Thank you. We have a very quick question for you before we move over, and that is scrap metal from the Q&As here. Can you talk a little bit more about, is the scrap metal from Europe actually sent to China or from other regions? Is scrap metal sent away?
Yes, absolutely. It is sent all over. The steel mills that you see in northern Germany, they buy a lot of scrap metal. Again, probably, I hazard at the percentage, but it's a ridiculously high percentage, like 30% of the steel actually comes from scrap. And the Chinese are the largest purchasers of scrap steel. So yeah, it's a seaborne commodity, just like anything else. And yes, the European scrap steel goes to China. Absolutely.
Okay, thank you. And Michael, you will stick along, and there are possibilities to ask you questions in the panel afterwards as well.
Absolutely.
Perfect. So if you have any more questions for Michael, just post them in the Q&As. And now we're moving on with our schedule, and I want to introduce you to the next speaker, and that is Professor Pekka Nurmi. You are the director of Penurco today, and you will be talking about the global sourcing of minerals for the battery revolution. So we're sticking to sort of a theme here. Interesting to hear, and the floor is all yours, Pekka.
Thank you, Lisa. Can you see my slides now?
Yes, that looks perfect.
Okay, good morning, everybody. Tere hommikusta, Eesti kolleegid. So I'm talking today about global sourcing of minerals for the battery revolution. And it's well known that the electrical car manufacturing is growing very fast in this century. And in 2040, it's estimated that about 60 million electric vehicles will be manufactured annually. It's much less talked and understood that what does this mean for the production of raw materials? Can we actually even do that? Can we mine and process enough the critical raw materials for battery manufacturing? And I will give you some thoughts about this in a moment. And what it means, anyway, it will mean a lot of new mining operations and expanding of mining and processing operations. This is a photo from Chile, from a lithium plant. So if we have a global view of the battery mineral production, you can see that it's concentrated only in a few countries. Cobalt is an extreme example because about 60% or even more is produced in Congo. Lithium comes mostly from Australia, Chile, and Argentina, although there are some minor operations under development even in Europe and in Canada. And then nickel, manganese, and graphite are not that critical because the resources are quite extensive and production comes from many countries. But there is also another aspect, not only the concentration of production, but also the sustainability of the societies of these countries is very bad. And as Congo, I have used here Transparency International corruption perception indexes. And you can see that the indexes in red can be ranked as very poor. Then we have medium indexes in orange, and most of the battery mineral production comes from these unsustainable societies. And there are only some countries like Australia, Canada, Chile, which are important producers and have also good societies. As a comparison, I put their Estonian number, which is 73. Then other important point is that actually China controls very much the trade flows of battery materials. And you can see in this graph that import is marked as in green and exports in red. And most of the global trade goes, or China is the major player in the trade. And this is the reason for that. Most of the batteries are today made in China. There are also important producers in the Far East, like Japan, South Korea, and after the Far East, US is the biggest producer. A lot of battery manufacturing is being developed in, for example, in Europe, but we are far behind. And can we ever match with China? Probably not. This is a table showing global reserves, production, and average price of the main battery minerals, and you can see that there are two expensive, or actually three quite expensive minerals, and then graphite and manganese. Manganese are not expensive, and they have huge global reserves compared to the production. But let's have a closer look. What does this mean? Actually, this is a quite busy histogram, but I will explain it shortly. So here we have the different battery minerals, production figures, global reserves, and global resources. And then how much we would need this particular mineral to make 200 million medium-sized electric car. And this 200 million comes from the EU goal to reach 200 million EVs by 2030. But if we think that globally we have about 1 billion cars, and if we change all the cars into EVs, so how much minerals would be needed? And here, note that this is logarithmic scale. And for cobalt, we would need to change all the cars, the passenger cars, we would need 1.7 times global cobalt reserves. It will not happen. For lithium, we would need 1/3 of global lithium reserves. For graphite, only 13% of global graphite reserves, and for nickel, about 16% of reserves. But we need to remember that this is only passenger cars. We have many other applications like heavy traffic, buses, maritime, airspace, all kinds of applications. So the conclusion here is that we need to change the battery chemistry to make this happen. With current chemistry, we can't make it. But actually, I think that copper may be the most critical metal for battery or electrification of things. Because we can maybe change the battery chemistry, but it's much more difficult to give up using copper. And today, about 20% of copper is used for transportation equipment. And global copper production is 23 million tons annually. Each EV will need 80 kilos of copper, and a bus 350 kilos of copper. So this means that 1 billion passenger EVs would need 4 times annual copper production. Then we have buses and other applications. So this will be very difficult to achieve this kind of expansion. And here is an estimate of copper demand, supply, and you can see that it doesn't look very, very nice at the moment. And we have globally extensive copper resources, but can we really build the big mines, new mines, and the processing capacity? May be difficult. Finland is an example of battery value chain, where we have big deposits, many deposits under development, but we have also the processing value chain. I will not go into details here. It's just an example. So my summary: raw material reserves, production, and refining capacity are getting scarce to supply the needs. Particularly cobalt, copper, and possibly nickel are in supply shortage risks. Global race for raw materials, processing capacity, and battery manufacturing is ongoing. Several political unstable countries are the main players. Strategic ownership controls of raw materials, trade, and manufacturing are becoming critical. China has made strategic acquisitions and investments and is the dominant player through the value chains. European Commission has a strategic action plan for batteries, emphasizing availability of raw materials from EU sources and EU processing and manufacturing capacity. But is it enough, and are we acting fast enough? Traceability would be an important factor to increase the competitiveness of sustainable countries. And finally, Northeastern Europe has great opportunities to contribute to the battery ecosystem development in Europe. Thank you. Aitäh.
Thank you. And Pekka, you will be with us for the panel discussion as well. Is that correct?
That's true. That's true.
Perfect, because only me have 100 questions on that report because it's so interesting. The path we are moving along requires so much more critical metals than you could ever imagine. So it's interesting perspective. So thank you, Pekka. And now we're moving on to the final speaker of today before we have a panel discussion. And that's you, Rutt. Hi.
Hi.
Welcome. So you are the head of mineral resources and applied geology at Tallinn University of Technology. And it will be really interesting to hear your speak. So the floor is all yours now as well.
Thank you, Lisa. And I'm going to talk about very specific subject, actually. And my presentation is titled as National Research Program ResTA targeting vanadium potential of Tremadocian black shales in Estonia. And the project only started last year and is planned to run until 2023. So I'm going to share the slides now, and I hope you can see the slides now. Okay.
Yes.
So, and as I said, I can only talk today about the general concept of the project and the expected outcomes, leaving the more serious discussion over results for next meetings. Why we target vanadium? It's quite clear. Vanadium is in critical raw material list of European Union starting from 2017, and its global demand is predicted to rise due to vanadium usage in battery technologies and for production of high-strength steels and superalloys. Of course, you can use them for 3D printing as well, vanadium in black shales is regarded as a major future resource type for this metal. But today, those resources remain largely unexploited due to complexity, organic-rich fine-grained ores, and technological challenges of metal extractions. So, what about vanadium in Baltoscandia? Cambrian Ordovician black shales in Baltic Basin are enriched in vanadium, and with hyper enrichment in some areas. And in Estonia, grounds of vanadium-rich black shales and shallow phosphorites in Tremadocian shallow marine complexes have been long known and quite extensively studied during last century, including co-exploitation of these resources. From Lauri Jooso's talk yesterday, you already are familiar with some details of black shale geology, so I'm going to stress only some points which are relevant for the project. The content of the organic matter in these black shales ranges from 15 to 20%, and mineral assemblage of these black shales is made up by potassium feldspar quartz and clay minerals, and pyrite content ranges from 2 to 6% in these black shales. What is also relevant for vanadium studies is that this complex has quite low thermal maturity. It has never reached the oil window, actually. But of course, if we talk about vanadium in Estonian black shales, we are actually talking about polymetallic ores. And in this graph, you can actually see enriched metals assemblage in this black shales as respect to continental crust average concentrations. And as you can see, vanadium is not so high compared to continental crust averages, the maximum 10 times above these values in continental crust. You can see find in this black shales, which is considerably lower enrichment compared to molybdenum and uranium. But anyway, vanadium is at the moment not economic as a single commodity, but if we consider the whole metal and semi-metal assemblage we have there, it is still reasonable to believe that this complex will be mined in foreseeable future. So some more specifics about vanadium in Tremadocian black soils in Estonia. The maximum vanadium content ranges here from 1,000 to 1,500 grams per ton based on historic analysis, but this historic values could be a little bit lower than the actual values because the analytical quality of the old data are not so good. What is also important is that vanadium distribution is spatially rather heterogeneous in this black shales, and this heterogeneity is could be followed in a lateral scale dimension as well in drill course sections. And this type of heterogeneity remains quite poorly understood. Furthermore, vanadium complexes in black shales are not known, and previous extraction studies show poor recovery of vanadium compared to other rich metals. And this is one reason why this project actually addresses specifically vanadium. What about ResTA project? The ResTA project is collaborative interdisciplinary research, which involves a research group from 2 universities, Tallinn University of Technology and University of Tartu, and from different disciplines like geology and chemical engineering. And analytical scope of this study involves a number of quite innovative techniques, including synchrotron-based spectroscopic studies for vanadium speciation, and will be focused mainly on vanadium-rich black shales from Tootsi and Aseri phosphorite deposit areas. So, but what are the main research questions of this study? One of the major research questions is actually which factors control vanadium enrichment, why we see such heterogeneous distribution patterns. And as we know, vanadium is quite a complex element if we look at natural behavior, and it can occur as polyvalent forms and is a redox sensitive element in oxygen depleted conditions. It enrichment organic rich sediments goes to reduction of dissolved vanadium in seawater, and in such environments, vanadium shows affinity to organic matter. But in the plaque shales of the tertiary formation, only moderate covariance between organic matter and vanadium could be followed. And vanadium hyperenrichment is not consistently related to organic matter richest varieties of the plaque shale. Instead, high covariance of vanadium and fine mineral fraction could be seen in vanadium-rich settings. Still, these covariance patterns of vanadium change from locality to locality, and we hypothesize at the moment that two different pathways might have acted in a primary sedimentary environment for vanadium enrichment. But the question about vanadium enrichment is inseparably related to the question how vanadium is speciated in these plaque shales. And this is also a rather relevant question if we talk about vanadium extraction from these plaque shales, the question in which complexes we can really find the vanadium today. And two types of the metal carriers are considered in the first order for these plaque shales. The first vanadium could present via organometallic complexes like vanadyl porphyrins, which are typical vanadium carriers in petroleums. And secondary, vanadium could appear as vanadium-rich phyllosilicate, like vanadium-rich yellites or yellite smectites. This type of carriers have been recorded in different plaque shales. In China, I knew that there are some information that alum shales also have this type of vanadium carriers. But at this moment, I should stop short going on with this subject, because this is something we are really going to go into during our studies. But very preliminary studies indicate that vanadium in Estonian plaque shale is bounded by at least two different complexes. And titanium oxides are additional vanadium carriers likely in vanadium-rich varieties of these plaque shales. So to sum up, expected results of the project. We seek to identify organic and mineral carriers of vanadium in Estonian Tremadocian plaque shales. We hope that new high-resolution dataset give us better basis to build more accurate predictive models for vanadium resources in local scale and in basinal scale. And we believe that improved knowledge of character of the ore will give us basis for tailoring efficient vanadium extraction technologies, so that this vanadium resources could really add up the European mineral wealth at some point. So, and if you are interested in of this project, you can actually access open data sets which are provided through Geological Research Information System EMABO. And of course, you can write me as well. And thank you.
Thank you. Very interesting. So that was a really specific case and project, but extremely interesting. And Rutt, you will stick along too for the panel, which we are moving into now. So if you have any questions regarding this, just post them in the Q&As. So with that, I want to move all of us into the panel session of today's conference. And now we are joined by 2 new people and the 3 speakers that you have already heard today. So first, I would like to get some pictures and some sound on from Håkan and from Gracina. Very welcome to the both of you.
Thank you. Thank you.
Hi. So Håkan, we can see you first of all. Would you like to start to introduce yourself a little bit? Who are you? What have you done? And what do you think about what you have heard today?
First 2 questions were rather big, but what I've heard today is very interesting, and yesterday as well. So there's a lot of issues to be discussed, and the panel is rather short, but let's see what we can do. I am Håkan Wahlberg. I am the head of an NGO in Sweden called GeoRange. I am also the managing director of Swedish Geological, which is a consultancy company, which used to be state-run, but now is a private consultancy company. And we work with development cooperation mostly, that is away from Sweden in developing countries. Maybe that's enough now. Yeah.
Yeah, that is perfect enough. So welcome, Gracina. Good to see you as well.
Hello to everybody, I'm Gražina Skridlaitė, a researcher from Nature Research Center in Lithuania, and I'm also a teacher at Vilnius University. And actually, I'm really impressed what I heard, and it's very interesting because we are a bit behind like Estonia, because we don't have such raw materials like, well, black shales, at least we have, but they are deep in the earth. They are not exposed, you know, they are much deeper, but we have some interesting subjects. I would say my doctoral thesis were on Varina iron ore deposit. It's a large deposit, it's iron ore, firstly, but now we study it a bit more careful, and we found a lot of other interesting things. And this deposit is in southeastern Lithuania, and it's only 200-300 meters deep beneath the sediments. And I mean, we found some phosphorus, like apatite enrichment, and some rare earth enrichment, and other things. And we're still studying origin of this deposit, because it's a complex one, and a lot of new things coming out. Well, and some other things, of course, we have to think of. But unfortunately, we have only quarries of building materials mostly. We stopped oil production already because it's not well economical anymore. And well, it's just some thoughts about our possibility. And it's very interesting to participate and to find some new solutions and maybe to some kind of what we have to think of in future.
Okay, yeah, perfect. So we had one question in the Q&As that I want to pose to you, Håkan and Gracina first, and then we can bring in the speakers as well. So that was a question from Alekos. Is the full potential in critical raw materials known in Northeastern Europe or in Europe overall? And if not, what is needed for us to actually assess this full potential? Gracina, do you want to start?
Well, I actually can't answer that question right now, you know, because it's still, well, Håkan wants to say something.
I could say something. Yeah, the full potential is not known, so that's very easy to answer. And in parts of Northeastern Europe, it is rather poorly known. And being, you know, I've worked more in Sweden than in the Baltics, so to say, but it's quite obvious that well, to me, it seems quite obvious that the potential in countries like Estonia is larger than I thought and knew. So there's quite a little bit more work that should and could be done. And my interest is often not really on the, well, I'm interested in exploration, but also you can't sort of do exploration and evaluate potential if you don't have a setup in a country where there is institutions and laws that allow subsequent extraction of those resources. And also if you don't have like a population that feels that this is overall a good idea. So I feel, of course, that you should do more work in this, like technical work, but you must also look at these softer issues at the same time, because yeah, there's ducks that needs to be put in a row, as they say in English, so that things will function in the future.
Good.
Definitely more potential, yes.
Yeah, exactly. So Rutt, let's bring you in here because you are very much in the center of the Estonian ecosystem when it comes to critical raw materials and so on. So this question, are we aware of the full potential? And so probably not, but how can we get there? How do you view that?
It's a very complicated question because I think there is no just one single activity we should do. But I think that meetings like that is a kind of very good way to actually build up this wider communities, because we do our things and here, but maybe we do not even communicate too much between the colleagues from Latvia or Lithuania. I think that I'm very favor of open access to data. So, and this is very important for exploration side. I think that only such a big open data sets could actually provide us better basis for settings like where we really have this low quality ores, where we can really work with really everything depends on optimization actually. And of course, if we are talking about deep ores or buried ores, it's we are probably looking for area for machine learning to go further to.
Yep, good.
Lisa,
okay, so and yeah.
Because I like the issue of geodata. This is the fun thing about panels. They go wherever they go.
They move where they want to move.
So they move where they want. I feel that this issue of having open access to geodata is extremely important. That's part of the parcel, right? And Estonia's history, we know of the sort of Russian influence, or the Russian thinking, or maybe the Soviet thinking, was that this geodata is some sort of a state secret that we should keep very sort of close to our chest, and we give it to certain companies, certain individuals that we really would like to work with. That's, in my opinion, and many others, not conducive to sort of developing the full potential. What you should do instead is to open up systems and allow more people to look at the data. So that's a very important part of the parcel. If you want to develop, for example, Estonia's mining sector, is to have open access to data and to make it not only open, make it easy for people to access it. Yeah.
And how do you do that, Håkan? How do you make it easy? Is it about digitalization? Is it about what consists of that?
Well, first of all, you need to have, sorry for being ignorant here about Estonia and policies, but you need to have a policy that this is open access, that this data is available free of charge. Not every country has that. In Sweden and Finland, it's definitely so that most of the data is available, and if there's a charge, it's a low charge. It's not expensive to get it. So first of all, the policy, that's politics, and then it's digitized. It's the systems to make this data available.
Yeah, good. So Gracina, how do you view that? How is it in Lithuania? Is it easy access? Do you have a lot of data? How are the policies focused?
Well, the data is the Geological survey. They have kind of open access, but I can't say it's for everything. It's still for a part of data, you know, and still you can access different documents, but I would say we don't have like real overview of all raw material. Like I mentioned, iron ore, I would say there are no proper calculations. I don't think it's even open for a society. It's just some data, it's open, some notes, some it's a geological survey, but usually it's for locals only. I think it's only in Lithuanian language, a lot of things. But they have some overview of all, at least some raw material, building materials, and some other things, you know, some calculations, and of course, water and peat and some other things, but not, I would say not all of them, and not everybody can access it right now. It's not prepared for open access, I would say.
Exactly. Okay, so
But
that's
they can
one
work
step.
on that. I mean, some overviews, some summary, they have it.
Yeah.
Yeah.
Good answer. Yeah. Okay, so when I have the three of you here, before we move into a little bit about production and so on, we have one question in the Q&As about collaboration and involvement. So the question is, how is research at universities involved with activities and projects carried out at geological surveys and industry across Northern European countries? Is this collaboration sufficient and specific? So Rutt, you are part of a university. How do you view that?
I think that in Estonia, the things are quite good in sense of cooperation with geological survey and universities. We have a number of projects running at the moment, not only the project I told before, the vanadium, where also survey has a part, but also concerning phosphorite deposits. But maybe the wider collaboration between not only inside of one country, but between institutions of different type in different countries is what we're still missing.
Exactly. Gracina, how do you view that?
Well, I can mention that we have had quite good collaboration with Geological Survey, and they ordered a lot of research projects, but it happened in the past. Nowadays, financing decreased considerably, and they are not like supporting research projects at Geological Survey anymore. Some ecological projects, of course, because we have a karst, you know, problem, and we have arsenic pollution nowadays. And these projects are supported, and of course they invite some scientists and some people from university and nature research center participating in these projects. But these may be mostly concerning ecological issues, not more of exploitation. And well, I would say we would need more input and maybe more even financing of research projects from Geological Survey and our government right now.
Håkan, how do you view that, maybe from a broader perspective, collaboration and what is needed to really create a good ecosystem?
I'm thinking that in the Baltic states there is no sort of mining tech clusters as yet. In Finland and Sweden we do have those, and they cooperate with academia very closely. So to build up that kind of cluster, that industrial mining tech knowledge takes time, and it's going to be a while before you have that in the Baltic states. So I'm thinking that there's an opportunity there. We're neighbors, or we live at least close by, and we have historical links and so on. There should be a possibility to improve that, and I'm thinking that is already on the cards in many ways, but that's what I would encourage. It's important, as you say, Lisa.
Exactly. Okay, good. So one final question, a little bit more along this exploration side of what we have heard today. We have a question in the Q&As. Is the exploration for strategic raw materials and rare elements bearing minerals in North Europe focused on geophysical remote sensing, geochemical sampling, or deep drilling? Is that too specific question? We have Pekka. Pekka, maybe we can let you in so that you can have a saying on this.
Yeah, thank you. I love to comment that as an exploration geologist, basically. And,
Perfect.
and first of all, it's very important to any country or every country to know the mineral resources as an important part of the national treasury. And all these open access to data and cooperation. Of course, these are important tools, but the basic thing is that we need the data, and we need to find out what minerals exist. That's very well known in Estonia already, but what are the real resources? We should do a lot of drilling to understand what are the resources. The old Soviet time data, unfortunately, it can be considered only as historic value. It's not good when you are doing bankable feasibility studies. So a lot of drilling would be needed. It would be also important to know what will be the suitable mining methods, beneficiation, environmental management, and so on. And is it environmentally or socially possible to extract the metals now or maybe in the coming decades? And countries should do scoping studies of the resources. But the data is the basics. But coming to the exploration, so exploration geologists or companies use all kinds of methods. It's not good to focus only one method. Geophysics, geochemistry, drilling, everything, geological modeling, everything is needed. And of course, it depends on the deposit, on the geology, but what is effective in any areas, but in a particular area. And finally, of course, countries should promote the social license to operate and do it in the best possible way.
Yeah, and we had a great deal of discussion surrounding social license to operate and social responsibility and so on yesterday as well. Really interesting. Håkan, do you want to put in some comments here?
I was on mute there, so I wasn't on the social license there. I feel there was a mention of a silver lining. I guess for mining people that are from the sector always understood that minerals and metals are needed for society, but the acceptance by large parts of society has been decreasing, right? And of course, it's been possible to buy metals and minerals from elsewhere. That's what Europe has been doing the last decades, right? But it's becoming crunch time, right? So this sector is a bottleneck, as you say. We need to produce more, and in doing that, we need to have that social license to operate. And the silver lining in all this is that most people, I believe, and it's also been shown by surveys, are rather reasonable, and they understand that mining needs to be done. They just rather have it somewhere else, but they understand that it needs to be done. So. And the majority of people would also agree that there are good projects and there are less good projects. So you can reach them. The ones that are very adamant that mining is a bad thing are a minority. So what do we do to get the social license? I think what we need to focus on is perhaps not focus on the ones that are extreme, because we won't change their minds. We need to focus on strengthening those that are reasonable or that understand sort of, yes, it's probably necessary to give them the tools to resist the more populist approaches that no mine should go ahead ever. So the sort of the majority of people, or whatever, the average Joe, as I say in English, is the one that we should, Joe and Jill, should target. Yeah, that was mine.
Good. So I want to have Pekka and Michael up on the screen to talk a little bit about maybe the downstream side of all this, because the two of you, you pointed out to tremendous potential, if we say so. I mean, these critical raw materials, the demand for them in, well, a current and in the near future, and in the very vast future, will be enormous. So how do a region like Northeastern Europe or a smaller country like Estonia or Lithuania actually make something out of this potential? Michael, do you want to start?
Sure. Let's use Estonia for example. Estonia's got they have a number of things going for that country, but probably the number one thing is geography. That its location is amazing. It's got a remarkably long coastline. It has at least 2 functioning like deep water ports. And the ability for Estonia to become a processor of, I go back to recycling, and I'm a big fan of Estonia actually being a recycler. It has power, it has access, it has reasonable access to bigger markets, that they could actually start recycling materials and extracting selected critical raw materials from scrap, and even going so far as to start using additive manufacturing or value added processes to actually start building an industrial sector. One of the things that no one's really addressing here is we're talking about the hunt and the search for, and to find critical raw materials and to produce battery metals and all this sort of stuff. But we've got to look further down the track, right? Because what often happens, and if you look at the material flows, that we produce the material, we throw it on a boat, and guess where it goes? It goes halfway around the earth to where the manufacturing actually starts taking place. And we've got to start actually thinking about it. If we're going to mine it, one of the rules is if we mine it, we've got to at least have our fingers in the actual upvaluing of that product. And if that is moving it closer towards a refined product, then so be it. But I live in a country that 60% of the economy leaves on a boat, every day. And the more you mine, that's how fast you mine it. You don't process it, you just crush it and you throw it on a boat. And the up value opportunity is so much lost. And I think we have to think about that in critical raw materials. It's not the rush to find them. It should be the rush to start doing something with them.
Yeah, excellent point. I mean, being from Sweden, we have the same conversation all the time.
Yeah, I may add here, of course, Finland is a good example here because we have a lot of, and Sweden as well. And Finland has systematically tried to build a battery mineral ecosystem, and it means that Finland, because we have raw materials, we want to do mining, but processing, battery material manufacturing, and down to the recycling. We should do everything, and the government plan is to build a multi-billion business around batteries, and I think it's the same in Sweden.
Yep.
Estonia is a smaller country, but you have your own strengths, and one of the strengths certainly are the resources, the natural resources, on top, of course, of recycling and other things which should be developed as well. But I strongly support that you study in Estonia your resources and make scoping or how and under which conditions those could be used. And certainly the rare earth elements would be of great interest. There will be a shortage of rare earth elements in the foreseeable future, and of course vanadium and some others, and then the phosphorus, which I know it's a hot topic in Estonia, but anyway, you should study and make calculations and evaluation how it could be mined. No matter, maybe it's not mined within the next 20 years, but I'm sure that one time in the future Estonia will be a big producer of phosphorus because it's so critical. You can't really, the number of people on the globe cannot live without using phosphorus.
Mm. So true. So we have a very, very specific question for you, Pekka, when it comes to the battery ecosystem from Juan. So he knows of Northvolt in Sweden, Freeport in Finland. Do you know of any others when it comes to the northern part of Europe or northeastern part of Europe? Where...
Well, already in Finland we have I don't know 40, 50 companies in the ecosystem, and the latest one was Matthew Johnson from UK, which make a memorandum of understanding with the city of Vaasa to make a battery material processing plant there using Terrafame nickel and cobalt sulfates. So the ecosystem is developing all the time, but it's very deep. People also mentioned here the research and development actions, and that's extremely important. So we need not only companies, we need also government support. We need to have a roadmap to see where we want to go, and then we need support. And we need, of course, all the players from academia, research centers, small and big companies. And it's a good Bat Circle project financed by Business Finland is a good example of such a project. It was a 20 million euro project, and there were about 40 players in the project. And now a new follow-up project about of the same size is being built in Finland. And
also on the battery.
It's battery. It's Bat Circle. So the one of the key focuses is in battery recycling. But it starts from mining or primary minerals. So it includes the whole value chain. And I like to take this opportunity and say my understanding of recycling, extremely important, certainly. But if you think about the future need of batteries, and then that each electric vehicle is the lifetime of a battery in the vehicle, maybe 10 or 15 years. So it will take 20 or 30 years until recycling can play an important role in the raw materials for batteries. So it's this is something people don't, or many people don't understand. They're talking a lot of recycling. We don't need mines, we need to recycle. That's not true in this kind of a business, which is exponentially growing.
Yeah, I heard some numbers about copper the other day, that it's purely impossible to look at recycled copper as an answer, because we will need to mine so much copper.
Is my favorite topic. Yeah. And the reason is that if you put copper in some application, it's typically 20 to 30 years there. So we are recycling copper now, which was produced maybe 20 years ago. And the production at that time was very low compared to the current needs. And copper recycling is very effective, something like 90%.
True.
But it's not the answer for many problems.
No.
Certainly extremely important.
Michael?
I'd just like to add something to what Pekka just said there, because I think it's a very, very important point that this newfound battery ecosystem and all about, high intensity storage cells, etc., that they're all being designed that almost 100% of the components can be recycled. So let's make a point to be perfectly clear here that we're actually closing the commodity loop with this new manufacturing. Right. So yeah, it may take 12 years or 20 years or whatever for that battery to run its life cycle, but at the end of the day, all of its components are going to be recycled into, whether it's going back into batteries or whatever it might be. One of the problems, and again, I think Pekka pointed it out, is that a lot of the technologies that are the technology or the processes that we require to actually recycle a lot of this stuff have not been developed yet. And that's really important. That's an important feature that, for a lot of the rare earths, for example, we actually don't know how to recycle them yet. We talk about it, and I talk about it all the time. Yeah, we got to recycle. But the reality is the chemistry set hasn't been developed yet to be able to do that. So we're kind of running before we're walking. And that's kind of one of the reasons why we're ending up with this situation where you have mountains and mountains of e-waste, right? Of busted up computers, etc. Is we actually haven't kind of got to the place yet where we can get the gold out. We managed to do that all right, but we still haven't been able to get all that other magical stuff out yet. And that's why we're sitting with this situation where we run before we could walk. So again, looking at aspirational consumerism, that, we should be buying stuff that we know is going to be recycled, or we can buy stuff that we know that we can change components, like that lovely phone that's developed in the Netherlands. All right, that's the way that our consumers and we as consumers are starting to shift.
Yeah, exactly. So moving on the consumer power.
Yeah, be mindful of that part.
Yeah.
And
so I mean, traceability. Yeah, sure, Pekka.
Yeah, I'd like to add something related to batteries. So I think that the battery chemistry will be changed. It may take 10, 20 years, and then to take the new, possibly much cheaper, not so much dependent on critical materials chemistry into batteries, build the new plants or change the existing plants. It's a long way from now. It may be 20, 30 years, but sure, I really believe after 20, 30 years, we have much smarter batteries, not dependent so much on critical raw materials, but we have 20 years or 30 years to go before that.
True. So let's make that the final words for the panel discussion. Thanks a million for all 5 of you. So Pekka and Michael, Håkan, Grazina and Rutt for participating. It has been a lively discussion. We have gotten a lot of questions on Q&As, on emails, on a little bit on the chat side as well. So also a great thank you to all of the attendees for being so active. It has been really interesting. So with that said, my summary of today, and maybe for yesterday as well, is potential. I mean, there are tremendous potential for Europe, but for Northeastern Europe as well, to be part of this potential that we see in critical raw materials and rare earth elements and so on, all across the value chain. What is needed is more of a strategy, roadmap, perspective, knowledge, and analytics. So if we get that in a good way, we could be an important player here. So it has been 2 great short days, and I would like to just leave the word one more time to Sirli before we log off to close the conference. So Sirli, are you with us?
I am. I hope some of the participants are still here, although we have only 2 minutes left. Dear all, on behalf of the organizers, thank you. Thank you for joining us yesterday and today. And I'm just stating the obvious. We have so many topics to cover. We have so many things to discuss. So hopefully you can find time in September to come to Estonia. Hopefully the COVID situation allows you to travel. We are organizing some interesting field trips, and I must say the quickest ones from you can actually come and join us in visiting the only rare earth metal processing industry in European Union. that is situated in Estonia. So please come to Tallinn, please come to Estonia, and we from Geological Survey of Estonia can share much more what we are actually doing, and our university can share their research studies with you. So collaboration and open access, everything that we will discuss it in September, hopefully this year. So thank you guys, and please be safe.
Perfect. So with that, million thank you to everyone. Hopefully we will meet in September and have a brilliant day. Goodbye.